A tower is 50 meters high. Okay, so then it is written, its shadow is X meters shorter when the sun's altitude is 45 degree than when it is 30 degree. You know the shadow. So when sun rays fall on this AB, its shadow is formed here. So at this one, AC is a shadow, right? AC is a shadow. So now this angle is 45 degree. So look at this. AC is a shadow. When sun rays falls on this, which one? AB. Like this, when sun rays falls on AB. So its shadow is formed here at AC. AC is the shadow. Okay. So that shadow makes an angle 45 degree, and this is the sun's altitude degree. Then when it is 60 degree, it is X meters shorter. That means this AC is a shadow when the angle of elevation is 45 degree or sun's altitude is 45 degree. Then another shadow is formed when it is 30 degree, and this AC is X meters shorter than that shadow. That means I will have to draw another shadow when the angle is smaller, like this. Here we are constructing a smaller angle, and this is D. Okay, and this angle is now 30 degree. Look at this, is smaller angle. Now this AC is X meters shorter than AD. AC is equal to AD minus X meters shorter than AD. That means what will be X here? AC or CD or AD, which part is X here? Can you tell me?
CD.
CD is X. I think all of you understood. Because AC is X meters shorter than AD means the CD is a X. I hope that part is clear to all of you. So now the question is, find the value of X. We want to find X. So now the calculation is very easy. First of all, you will take the triangle BAC, apply tan 45, you will get AC, right? AC will be 50 meters because tan 45 is 1. Then you will take the triangle BAD, and then you will apply tan 30. You can find AD, and then you will subtract. X is AD minus AC. So that is a calculation part. So please draw this diagram. If there is any doubt, so for explanation, you can ask based on this question number 85. If not, start the calculation part. So first of all, we take the triangle BAC. In triangle BAC, we have tan 45 degree is equal to, it will be like this, AB upon AC. Tan 45 is 1. So 1 is equal to 50 upon AC. So AC is 50 meters. We got AC is 50 meters. Okay, so now we'll take the triangle BAD. In triangle BAD, tan 30 degree is equal to AB upon AD As you know, tan 30 is how. So now we will subtract. We want to find x. X is equal to AD minus AC. That's equal to 50 root 3 minus 50. So I will take 50 outside, then root 3 minus 1. Root 3 minus 1 is 1.732. And this minus 1 means 50 into 0.732. Under 6 meters is the answer. Okay, so we have completed now question number 85. Also finished question number 86. Yes. Okay, see question number 86. Prove that tan raised to 4 theta plus sec square theta is equal to sec raised to 4 theta minus tan square theta. Okay, this is the question. Prove that tan raised to 4 theta plus sec square theta is equal to sec raised to 4 theta minus tan square theta. Left hand side. That is tan raised to 4 theta plus sec square theta. So this tan raised to 4 theta means tan square theta the whole square, or t square as it is, plus sec square theta. So this is for tan square theta. It is sec square theta minus 1, then the whole square as the same. So now this is of the form a minus b the whole square, a square minus 2ab plus b square. So this is going to be sec raised to 4 theta minus 2 sec square theta plus 1 and plus sec square theta. Okay, so now look at these two like terms. I hope you understood this. I have applied the formula a minus b the whole square. So now look at these two, minus 2 sec square theta plus sec square theta. So it will be minus sec square theta, right? So we can write this sec raised to 4 theta, then plus 1, then minus sec square theta. Okay, so if I take, we have the formula for sec square theta minus 1. So if I take a minus sign outside from these two, if I take a minus outside, we can write that one in the form sec square theta minus 1. So I'm going to take a minus outside, then this will be sec square theta minus 1. And again, as we applied there in the beginning, sec square theta minus 1. So this is our key formula used here. Sec square theta minus 1 is tan square theta. So instead of that sec square theta minus 1, we will write tan square theta. So hence it is proved. So this is the completion of question number 86. I hope you all understood this. Stations due south of a leaning tower which leans towards north. So we'll draw a leaning tower. So I'm going to draw like this. This is the leaning tower. Okay. and it leans towards north. Okay, so this direction I am taking north. So let this be the leaning tower and two stations. So here two stations we take, A and B, be two stations. A and B be two stations, that is on the south, and this is the leaning tower. It leans towards the north. That is in question number 61. That's the difference in this question. Normally, in all questions we discuss about vertical towers, it makes an angle 90 degree with the ground, but here it is a leaning tower. So I'll mark this one C, and this is E. So CE is the leaning tower here. CE is the leaning tower. Then two stations due south of a leaning tower which leans towards north are at distances A and B from its foot. That means this A and B are at distances A and B from its foot, which means this distance is A, which one? The C is the foot of the tower, of the leaning tower, and to the second station the distance is B. Okay, so these are given. Then it is written, all of you understood till here. C is the leaning tower, and two stations due south of the leaning tower, which leans towards the leaning tower leans towards north, are at distances A and B from its foot. The two stations are at distances A and B from its foot. If alpha and beta are the angles of elevation of the top of the tower from these stations. So from these stations, that means from A to E, it is alpha, the angle of elevation is beta. So here the difference of this question is leaning tower. The C is the leaning tower. Okay, so now again it is written, all of you understood till this part, alpha and beta are the angles of elevation of the top of the tower from these stations. Now, through that, its inclination theta to the horizontal. Whose inclination? This tower's, right? So the tower, it makes an inclination theta with the horizontal. For that, I will draw a vertical height like this, because in trigonometry, without this 90-degree angle, we cannot calculate. So this is the inclination towards the of the tower. Okay, so theta. So this angle is theta. So I will mark this one D. Okay, so here C is the tower, not ED. D is not the tower. Instead, C is the leaning tower. So this one I completed to get the right triangle. E cot alpha minus A cot beta upon B minus A. This is the question. We want to prove this one. So I'll take, for our convenience, let H be the height DE. So we'll remove H at the end. We have to remove H at the end. And the CD is X. Okay, X also will remove at the end. In the answer, there is no H and X. Okay, so now I am going to take cot of all these angles, because cot theta, cot alpha, cot beta. So I will take these three. First of all, I will take cot theta, then cot alpha, cot beta, and then cot alpha. These three angles I am going to take. First of all, cot theta. See how to take cot theta. You know, cot is adjacent side by opposite side, right? Adjacent side by opposite side. So I'm going to take the triangle CDE. So in triangle CDE, we have cot theta is equal to adjacent side by opposite side, X by H. And from here you will get X is equal to H cot theta. This is equation number 1. And then I will take cot beta. From the next triangle, I am going to take cot beta. This triangle, in triangle BDE, we are allowed to take only right triangles to apply trigonometry. So in triangle BDE, this one, BDE, we have cot beta is equal to by opposite side, because usually we take tan, but here it is unusual, we are taking cot. So from here, B cot beta is equal to B plus X. And from there, B is equal to how much? H cot beta minus X. And here I will substitute for X. From this equation, we can substitute for X. So we'll get B is equal to H cot beta minus H cot theta. Or we can write B is equal to H into cot beta minus cot theta. This is the second equation. Cot is adjacent side by hypotenuse. Sorry, adjacent side by opposite side. So from here, H cot alpha is equal to A plus X. And from there, A is equal to how much we get? H cot alpha and then minus X. And this X also we will substitute. That is, A is equal to H cot alpha minus X. X is how much? H cot theta. That means A is equal to H into cot alpha minus cot theta. This is the third equation. Okay, so now we have to remove H. X already we removed. So for that, we will divide these two. If you divide these two, H will go. H is not there as a part of answer. So we are going to divide these two. That means equations 3 by 2. So when we divide 3 by 2, we'll get left hand side is A by B is equal to, so see how this H is removing, H into cot alpha minus cot theta upon H into cot beta minus cot theta. So we cut these two, H is removed. Then multiply this and we have to collect cot theta on one side. You will get cot theta. So A into cot beta minus cot theta is equal to B into cot alpha minus cot theta. Then we will open this bracket, theta. I am taking these terms together. This one and this one. Okay, so we'll take cot theta outside. So when we take cot theta outside, we'll get cot theta into how much it is? B minus A is equal to B cot alpha minus A cot beta. So that is answer, right? Cot theta is equal to, we bring it to the denominator, B cot alpha minus A cot beta divided by, what is that? P minus A. Hence it is proved. So this is the complete answer for this question.